Okay, so we're still at the first step of our algorithm, which is creating an ARP request that asks for a specific IP and is sent to the broadcast MAC address. Now we've broken this down to even smaller parts. So the first part was to create an ARP request asking about a specific IP. And we achieved this in the previous lecture, and we already have that stored in a variable called ARP request. We verified it has the right result by printing the summary of this packet. The next thing that we need to do is to set the destination MAC to the broadcast MAC address to make sure that this will be sent to all the clients on the same network. Now, in order to do this, we need to use an Ethernet frame because, like I said, data in networks is sent using the MAC address, not the IP address. The MAC address is a physical address that is engraved on each network card, and the source MAC and the destination MAC is set in the Ethernet part of each packet, not in any other part. Therefore, we need to create an Ethernet frame and then append our ARP request to it later on. So for this lecture, as we usually do, we're going to forget about everything and we're going to focus on creating an Ethernet frame that will be sent to the broadcast MAC address. Now, creating this is very similar to the way that we created the ARP request. So I'm going to delete this line. And in here, we're going to say broadcast is equal to, and we're going to say scapy.ether to create an Ethernet frame and put two brackets. So very similar to the way we were creating an ARP packet, all we're doing is we're saying scapy.ether. This will create an Ethernet object for us from Scapy using a class that's implemented by Scapy, and it's going to store an instance of that in broadcast in a variable called broadcast. Again, you can call these variables whatever you want. I'm just using these names because I think they're meaningful, they make sense to me. Now, just like we had to set the IP in the previous lecture when we were creating the ARP, in here we need to set the MAC address to the broadcast MAC address. The whole point of using ether in here is to make sure that the packet that we'll be sending will be sent to the broadcast MAC address and not to only one device. So we need to set the destination MAC in here to the MAC of the broadcast. Now again, we don't know how to do this because we don't know the field name that's used for the destination MAC address. Therefore, just like we did before, in order to get the names of all the fields that we can set for the other class or for the other object, we can use the scapy.ls function. And in here, we're going to put the name of the class that we want to get information about. So in the previous lecture, we put scapy.arp. Right now, we're going to put scapy.ether. And then we'll run our code. And as you can see, it's given us the list of all the fields that we can set and the description of them. So, as we know, we need to set the destination MAC to the MAC address of the broadcast. So to do this, we're going to need to use the dest in here. Again, you can use that in two ways. You can either do broadcast.dst equals and put the MAC address, or you can do it the same way that we did it in here. Just copy all of this and set the dest field when you create the object. So you just put that in here between the two brackets. Now, the broadcast MAC address, like I said, it's actually a virtual MAC address. It's something that doesn't exist really, but when you send something to it, all clients will receive it in the network. So the value for this is 6Fs. So it's 1, 2, 3, 4, 5, 6, and that's it. Now, like we did before, we can do print broadcast.summary and clear all of this and run our code again. And as you can see, it's going to be an Ethernet packet. It's going to be sent from this MAC address, which is the MAC address of my computer right now of ETH0. And it's going to be sent to this MAC address, which is the MAC address of the broadcast. Now, if we go back to our algorithm, And look at the first step. We need to use ARP to ask who has a specific IP. And we already have that in our ARP request variable using the ARP class or the object from Scapy. And the next step is to set the destination MAC to the broadcast MAC. And again, we just implemented that. And the frame that does that is stored in the broadcast variable in here. So now all we have to do is just combine these two packets into one packet, and we'll have our first step done. Now to do this in Scapy, you can just use the /. So we're going to create a final packet which will contain both. So we're going to call this ARP request broadcast. And again, this is just a variable name. You can call it whatever you want. And this is going to be the combination of the two that we created so far. So this will be our broadcast. And then I'm appending the ARP part to it using the /, and we're adding the ARP request packet that we created in here. So again, all we're doing now is we're just creating a new packet, which is the combination of the two that we created in the previous two lectures, and we're combining them using the / because Scapy allows us to do that. Now, we can print the summary of this. And you'll see that this has an either part and it has an ARP part. And in the ARP part, it's asking who has this IP address, which is the IP that we're passing here. And it's saying return the result to this IP, which is my IP. Now we can also print something useful by doing the name of the packet, which is ARP request broadcast.show. And what this will do, it'll show us more details about the contents of this packet. So let's do this and see what we get. Now we can actually use the show method on all the other packets. So we can actually just do ARP request.show. And we will do our broadcast.show. And we have already our ARP request broadcast.show. And what this will do, it'll show us the details of each of these packets. So let's see what's the differences between these two and what happens when we combine them in the last statement in here. So let's run this. And let's analyze that. So the first result here is this ARP request. So as you can see, it's an ARP request. It's asking who has. It's being sent from our MAC address, from our IP, and it's directed to 10.0.2.1/24, which means all the IPs or the possible IPs in our subnet. Now note the IP here is the same as the IP that we requested when we called the function. Then the next show is the show in here. So this is this one right here. And as you can see, this contains Ethernet data. The destination is the broadcast MAC address. Again, it's what we set in here. And the source is the MAC address of my ETH0. And finally, the last show in here is the show of the ARP request broadcast, which is the combination of the two. And if we look at that, you can see that this packet right now contains two parts. Let me make this bigger. So it has an Ethernet part, which will make sure that this packet is directed to the broadcast MAC address. And it also has an ARP part, which will ask who has, and it will ask about the IPs in the subnet, which are the IPs that we pass to the function. So as you can see, this is a combination of the two variables or the two objects that we created before. Now, in the next lectures, we're going to continue through the algorithm. We'll see how we can send this packet, receive the response, parse the response, and discover all clients on the same network.